Good morning, good afternoon, good evening, wherever you are. I hope you've smiled today. My name is Trisha Howard, aka Trisha Kicks Sass, and I'm, you guessed it, thrilled to have Ryan Barnett on with me today. Hello, Ryan.
Hey, Trisha, how you doing?
I'm doing fantastic. Now
Cool.
that you're here, of course. Um,
Yay.
so before we get going, do you mind just introducing yourself and letting people know, who you are and what you do?
Sure. Yes, I'm a senior threat research manager. Basically, my team is in charge of the App and API Protector product and the Adaptive Security Engine, which also there was a Bright Talk, a thing we did recently. If you're interested in Adaptive Security Engine, go check that out. Been at Akamai 10 years and been doing web app defense for over 20. So I've been in the WAF space since about the beginning.
I love that. I love that. Yes,
Yeah.
definitely. If you're thinking about anything WAF, Ryan is the one that you want to talk to and listen to, which is precisely why he's on here today. Um,
Yep.
so for those of you who are returning, welcome back and thank you. And for those of you who are new, welcome front question mark. I think I'm funny. Uh, what I'm going to do is run through a couple of things that we have had going on here at Akamai Security Intelligence Group, and then we will jump right in to some awesome research that Ryan and his daughter actually did. So there's your little teaser. Um, so everything that or we talk about today, any links will be in the attachments tab. So definitely check that out. If there's anything missing or you want more information on it, you can reach out to us directly. That information will be on the end slide. Okay, got through that. Now let's move on to the tapas. First things first, we have a state of the internet report on abuse and fraud. It is definitely worth a read. There's so much going on in this space right now, especially when we're talking about like AI and LLM powered bots and the attacks that they are doing against APIs and against other LLMs, et cetera, forever and always. Definitely check that out. I've included the link to the overview blog here, just so you can get a kind of taste of what it is, and then you'll definitely want to order more, aka the entire SOTI. Tons of good information in there. And the other thing, speaking on the same LLM trend, is we had a piece of research from our Akamai Hunt team of a new strain of malware that is actually hiding behind a legitimate LLM, and it is just effectively hiding in the shadows. So you'll definitely want to definitely want to check that one out. Anything that comes out of the Hunt team is usually pretty cool. So again, like I said, all of those links are right there. And now that I am done with my little monologue, we can jump into the Unicode research. So obviously, as you heard, audience, Ryan has been doing this a while and really knows his stuff. And I love this research. I've seen it. I've seen you present it, and I am really grateful for that. In fact, the entire presentation is also in these show notes, so you'll want to watch that too. But I love your analogy on how these things work, the idea of a digital telephone game. So do you mind just starting there and going on?
Yeah. Yeah. We were both talking. We both love analogies, right? To
Yes.
make sure everybody's on the same page conceptually before we dive down some rabbit hole. Um, the idea was that most people have played at some point in their life when they were younger at a party or something, the telephone game where you're whispering in somebody's ear and then they whisper it and they whisper it and it just goes down the line. And for a variety of reasons, because people forget what they said, they didn't hear it, they make something up, the data changes. And then at the very end, the person says, I think this is what I heard. And it's obviously very different. People laugh and all that stuff. So the whole idea here was setting that stage was say, now take this to the web. And instead of talking in people's ears, you have all these different intermediary systems that pass through. And then you get to an application, but still in the application, there's all sorts of places that data flows to, whether it's databases or other stuff. So the big question is along the way, is that data changing? And a real big takeaway, again, even for today's talk that we're having here, if there's one thing that people get out of this and related to the Unicode problem, it's referencing CWE 180, right? So common weakness enumeration. And we were seeing this pattern that the problem is they're getting two things wrong, this order of operation, where they're doing a security check first, and then afterwards changing the data. bad, right? You got
Oof.
switch those around. Yeah. So it was a common symptom. We found a bunch of public use cases for the talk because we wanted people to be able to go out and see real examples and all of that. But these are all things we've seen over the years here at what we do at Akamai. If there is a problem in our customer's web application, and we're digging into it to figure out, well, why did this happen? Why did we not see this attack? And it's like, oh, it wasn't an attack payload when we looked at it.
Yep.
Later on, it got changed into something that worked after the fact. So the CWE is very relevant in a third-party, cloud-based WAF kind of a scenario, but it
Right.
also happens inside the code. So um,
That's a great
just a
call out.
couple, yeah, the Cliff Notes version, since we're on the SIG download, right? We got to compress this, right?
That's
Yeah,
right.
exactly.
The zip
Just
file.
yeah, so just a couple high-level things. We already talked about CW 180. That's the big takeaway. But with all of these application pipelines, the question is like at each step, what's happening here and where can there be problems? Another big thing is anywhere there's doing URL decoding, is it basically Unicode aware? Is it multi-byte aware? Does it know how to decode it properly into like a single glyph and a single character? You'd be surprised. There's a lot of URL decoders that are not, and that can cause problems. You'll get jumbled data, and before you even get to the actual using of the data, you don't decode it properly, it's an issue. The other one is very well known in the industry for a long time. It's confusables, visual lookalikes. So anybody listening or watching this, for the longest time, those are the phishing domains, right? Where they have something that looks like it's, whatever, PayPal.com, but it's not. They use a weird
Right.
looking A
It's a 1
and
instead
kind
of
of
an L.
exactly. So it's been around a long time, but in the web applications, it is a big problem. Also, primarily on Microsoft platforms. They call it something a little different. It's called best fit mapping, but that's what they're doing. They're taking a character and they're saying, oh, well, depending on the code page, what language you want to use for this application, we don't have that character. Let's use this other one instead.
Right.
Won't
Yep.
cause any problems, right? Sometimes it does. That's a
Ugh.
big issue. And then a couple other ones just to kind of wrap up this section here. But there's something that we call byte truncation. And we were trying to figure out the right name for this, and we couldn't find anybody talking about this exact problem. So I want to explain what we're talking about. And that is you have data you send across the web. It's UTF-8 encoded. We talked about decoding. Okay, it decodes properly. But then if data is going to be held in memory to be used by some application or something, you get into this scenario of big endian and little endian. These are just terminologies of how the data is. And are you reading the most significant byte, the least significant byte? Like, how are you handling this data? So, what we were identifying, and it's hard because our customers' applications are black boxes. We don't own them, we
Right.
don't own the apps, but we could tell the behaviors. And it seems like it was a little endian situation where they're taking the least significant byte of data and just using it. Well, then it results in a completely different character than if you use it that way, because the Unicode character may be multiple bytes long. So it's really weird, this behavior that we see, but threat actors and bug hunters do know about this. So they're trying these techniques. So it's very tricky. And then the final two scenarios here, again, these aren't directly like Unicode normalization, but think about in your applications, anywhere you're doing text casing changes, like, oh, let's change everything to uppercase, change it to lowercase, change it to title case. Most people do not think, oh, that's a Unicode normalization thing, but they have mapping rules where if you take a certain Unicode character in a different language and you apply like an uppercase to it, it may change to an ASCII character. It's unexpected. It's these weird scenarios like that. And kind of the final one is in databases. Data that's stored in a database, there's something called a collation, and you can configure how you want to handle this. So if you're taking data and you want to do a comparison with some data that's saved in a database, it depending on your collation setting, and this is an issue in MySQL, is it may ignore accent characters. So when you think about all these different languages, right, you have accents and umlauts and all these like other things, those may be ignored. And so again, this is maybe not expected because there's default settings. So all of these are crazy situations that we had to research with my daughter, which was a blast. And then we made Dojo Labs on, actually, you can see up behind me here, Yes We Hack, a
Aw.
bug bounty platform. Dojo Labs is awesome. It's like a CTF place where you can create stuff, so people can go out and try this on their own and try out all the stuff we've talked about. So
Amazing.
that's the quick summary of what our talk was. But yeah, go check out the video if you want to hear the full thing.
Oh, definitely. It's certainly worth watching multiple times, frankly, to kind of digest it all, because it's an interesting problem. We've said this for years, like you can't secure what you can't see, but it's a totally different ballgame whenever you're literally seeing it and it's just not the same thing.
Yeah.
Woof. Talk about hiding in
Yep.
plain sight, right?
Yeah.
And so on that note,
Yep.
obviously technology moves very quickly, and we opened the show with LLM stuff, as everyone else is too. Have
Yep.
you seen anything specific to Unicode, like attack vectors or anything with regard to LLMs?
Yeah, exactly. Referencing what we were just talking about. Um, Obviously, Akamai has a product now called Firewall, right, for AI,
Hmm.
and protecting your LLMs from this. So that's not my team's focus, but our research teams talk to each other. We always collaborate, right? Because
Yeah.
everybody's checking their own stuff, saying, "Oh, maybe you'd be interested in this." So what we were just talking about, there's an issue called invisible Unicode. Now, what's interesting about it, yeah, visible. Um, is a couple different things. There's Unicode characters where this has a purpose, right? They created these characters and this behavior for a reason. Um, and one of the best examples I heard is like think about emojis that you see, whatever it may be. Like you take a wizard character and they got like whatever, like a gray hat, and you say, no, I want a black hat. Well, one of these, one of these Unicode characters, it's invisible in and of itself, but it's a modifier. So it's like, oh, when you're going to render, whatever this glyph is, change the color to gray to black or whatever it may be. So that's like the legit reason why you would have these. They're modifiers. Well, part of the modifier behavior, however, is to do things called zero width length. So if something is zero width and you try and render it, it's invisible. You don't show it, right? So
Oh,
what you can do is say in the world of LLMs and doing like prompt injection, where you say, hey, give me your system prompt, because they want to see exactly what's happening under the hood. LLMs are supposed to block that. If they see that, then that's a safety concern, right? There should be some sort of guardrails and say you
right.
can't do that. Well, part of
Should.
the problem here, yeah, should is the key word. So it should be happening. Is if you take that give me, your system prompt, but you modify it with all these Unicode invisible characters. Yes, visually, if it's rendered, there's nothing to show, but the data is all still there. The LLMs, visibility is not a concern to an LLM, right? Because the data gets tokenized, and then it's being able to look to say, okay, what's similar? What are they asking for? And by applying these modifiers to make it invisible, the actual tokens and the way that they're looking at it, they say, oh, this doesn't match the malicious thing that we know because it's so different because of these tokens, where they may
Oh.
then respond to it, right? And another key thing, and I'll mention this because as we were talking, I just got back from a customer event in Chicago. We were talking all about AI and the
Mhm.
security concerns, and customers have concerns, around these areas. And there's a key thing that a lot of these processes may be using today, which is human in the loop. You still have AI to do certain things. You've automated and you're doing all this, but because of regulations and different things, you may have to have a human that does a final stamp of approval on something,
Mhm.
right? So all the
Mhm.
hard work is done, and there's a yeah, this is good. Okay, next. Well, think about this. There could be data in there that is not renderable. So it doesn't mean that everything is invisible. You could have certain stuff that's showing normally.
Woof.
You add stuff on the end. The human in the loop looks at it in a browser or whatever. Anything that honors Unicode in rendering that would be invisible, they rubber stamp it and it goes on its way. And then you have scenarios where it could cause problems on the back end, right?
Yeah.
Because then you can run into things which is indirect prompt injection. Like that's made it through, it's stored somewhere. Yeah, but this is what we're talking about with customers, that you may have something such as our firewall for AI on the front side. You're monitoring that front door, but if something comes in through a different channel and gets imported where it's not being protected, it could execute, right? So the one thing that the customers are very thankful for, I was talking about this with them yesterday, is we tested this on our product because we do this research. That's what researchers do. We find this and we said, let's go test our stuff. Thankfully, there's multiple different ways we detect this.
Yeah.
and we can block it. But yeah, it can cause all sorts of problems. Also, looking through logs, the stuff won't be
Oh yeah.
there. Like anything that can render, you're not going to see data. It's going to be missing. It's crazy.
Wow. That's so wild. I want to do a second talk with you on this at some point because this is just it's truly fascinating. And wow, how do you defend against that? I'm not asking. It's more, but wow.
Yeah,
Um, oh,
it
I
gets
yeah,
crazy. Yeah.
it is. It really, really is. Man, I'm constantly surprised at technology and what it can do and can't do. And I also am constantly surprised at how quickly this show goes. We are already out of time. So I wanted
Yeah, sure.
to give you just an opportunity. Is there anything else, any nuggets of wisdom you want to share before we wrap
Um,
up?
yeah, like you said, we're always doing interesting things. So it's kind of sticking a little bit on topic here. Model Context Protocol, MCP. A lot of our customers are also deploying those. That's part of this agentic AI, ecosystem.
Hmm.
And so we're doing some research to get some observability to understand the adoption rates that the customers are doing because they don't always tell us. They'll deploy whatever they're deploying, and it's actually behind our products. So we are seeing adoption. We're observing some traffic. And the other thing, because we are threat research, we're interested to say, okay, is there any like attacks happening, threat actors, like what's going on? So one thing we always do tout as Akamai is not just the amount of data, but trying to turn it into intelligence, right? We've
Mm,
got a lot of our systems around the globe, but squeezing that good intel. And going back to our analogy that we were talking about, I did some research earlier in the week prepping for this customer show, and I wanted to find out, are bad guys looking for MCP servers? Right? Because it's early adoption phase right here, and it might not be worthwhile for threat actors just wholesale
mm,
change.
mhm.
But I was able to go look on our the vast network of data, and the analogy I was giving when I was explaining this also to a customer is it's kind of like when we were all going to the airport to travel for the show. You're going through TSA, you get there, and they ask for your boarding pass, and you don't have one. And like, okay, what are you doing here? You're not supposed to be here. You don't have this. So essentially, we can identify similar behavior on our network. If something hits one of our edge nodes and they don't have the right information, to us, that's an absolute threat intel signal. And so I was able to look at a lot of threat actors searching for MCP servers.
That's a great
So
practical
threat
point.
actors are looking for it. So customers do need to be aware, or anybody deploying these, they will be found. They will be found quickly. Don't think we're going to put it up and then secure it later. That's not a good strategy.
Hope
So
it's not a
that's it.
strategy.
Yeah, yeah,
That's it.
exactly.
Amazing. I love the boarding pass analogy. I think it's brilliant, and I would love
Cool.
to, if you're willing, to come back on at some point and talk about the rest of that. Um,
Absolutely.
uh, Thank you, everybody, for joining, and thank you so much, Ryan, for an incredible episode. I'll see you again on the December 17th, y'all, for episode 25. Can't believe that. As I mentioned before, anything we mentioned today will be in the attachments tab, and reach out to us directly if you liked this, didn't like it, questions, comments, concerns, jokes, songs, whatever you got. We want to hear them. So thank you very much, everybody, and Cybernara, y'all.
Have a great day.